Hello friends, I welcome you all to my channel. This video is part of the playlist Python Basics Programming Beginner's Daily Dose, where I come up with videos on fundamental concepts of Python so that the beginner level Python developers or programmers will get a better insight of how things work in Python behind the scenes. If you are not subscribed to my channel, I will request to please support me by subscribing to my channel, and if my videos are beneficial to you, then please like my videos, share them with your friends, and please do not forget to press the bell icon so that you will be notified by my future videos. In this video, in this part 2 video, I will discuss about how deep copy of objects works in Python. So let's get started. Okay, so I briefly, roughly sketched the algorithm of how deep copy works in Python. So in the part 1 of the video, I've already discussed. If you have not watched part 1, I highly suggest you to please first watch the part 1 of the video and then continue to watch this video. In part 1, we discussed that there is a module copy, and inside that module we have two functions, copy.copy. One is the copy which creates a shallow copy of an object. It takes an argument, an object, and there is another function, deep copy, which creates a deep copy of an object which is passed as an argument. So in this video we are discussing about deep copy. So on the right hand side, you can see I've written down the algorithm of deep copy, where x is the input object. Now how it works: if x is numeric or string or range, that is immutable data type, not including a tuple. We will discuss tuple later on. So if x is numeric or string or range, then it will simply return x. It will simply return x. The reason being, since x is numeric, string and range, no way you can modify the content of x because they are already immutable data. So it makes no sense to create another object, new object, and have the same content. So it merely returns x. Now if x is a tuple, we have two scenarios. If all the elements of tuple are immutable data type, meaning if all the elements of the tuple are either numeric or string or range, then simply the tuple x will be returned. In the similar reason applies if all the elements of the tuple are immutable, no way you can modify them. So there is no need to create a new object with the same content. So it will simply return x if all the elements of x, which is a tuple, are immutable. By immutable I mean if they are either numeric, string, or range. Now what if an element of a tuple is also a tuple? Well, in that case the algorithm will work recursively. If it's a tuple, then again the algorithm will recursively see that it's a tuple, and the algorithm will follows as we are discussing now. So if x is a tuple and all the elements are immutable, meaning all the elements are either numeric, string, or range, it will simply return the tuple, that is x. Now if x, which is a tuple, contains at least one mutable data element, by mutable data element I mean it's a list or it's a set or dictionary. For the sake of this video, I will only consider data types, built-in data types, which are numeric, string, range, tuple, set, list, and dictionaries. About the custom user-defined functions, classes, I will discuss later on. So if the tuple, in the second case, else part, if the tuple contains at least one data element which is mutable, meaning it is either a list or set or a dictionary, then what will happen is an empty list will be created, a new empty list will be created, and it will iterate over all the elements of x. It will iterate over all the elements of x and it will create a deep copy of those elements. I mean, the algorithm will again work recursively. It will again call copy.deep copy E, where E is an element of X, and that deep copy it will append to L, the empty list, and finally from all the elements of the L, it will create a new tuple, and the new tuple will be returned. I will explain all these things in the code later on, very shortly. I'm just quickly discussing the algorithm. Now, if X is a list or set, if X is a list or set, then the algorithm will work similarly for exactly the way it was working when X was a tuple, but at least one element of the tuple was a mutable data. So the else part, if X is a list or set, the algorithm will work exactly same as the else part of point number 2, that is X is a tuple, but at least one element of the tuple is a mutable data. Okay. Now, if X is a dictionary, what happens is a new dictionary, empty dictionary will be created, and it will iterate over all the keys of the X, and it will copy it will make a deep copy of the value of xk, of the value of the key k in X, deep copy of that, and then it will add key k to y and assign the value to yk to the deep copy of xk, and finally it will return a y. Okay. Now let's try to understand all these the steps in code. So okay, I will try to be compact in the coding part. So let's say I have a number. Let's start with numeric. First I have to import the copy module. Okay, let's say I have a number, let's say whatever, something n, and let's say if I do n2 equals to copy dot deep copy n, so I'm creating a deep copy of a numeric data n2, and if I check n2 is n, it is true, meaning the object n2, the n2 the variable n2 and n are pointing to the same object. They are having these variables in Python are called targets. These targets n2 and n are bind to the same object. That is why their ID is same. So as I've already discussed in the previous video, the is operator checks whether two variables are pointing to the same object or not. So this is true. Let's take a string, and I do create a deep copy of this string, and I check is s, it is true. So for numbered and string, it is merely returning the object itself. Now let's say range. Let's say we have a range something and we create a deep copy of this range, and we see that both are same, R2 and R are pointing to the same object, meaning they are the same object. So we saw for numeric, string and range. Now let's see tuple. Let's have a tuple where all the elements are immutable data, that is all the elements are either string or numeric or even a range, even a range, or even another tuple with all immutable data. So this is a tuple where all the elements, data elements, are immutable. They will never change. Okay. Now if I create a deep copy, of this tuple and see if same or not, it is true. You see, T2 and T are the same object. This operator checks whether two objects are same. I mean the two variables are bind to the same object or not. So T2 is T. Now, since this happened because all the elements of T were immutable data type. Now, let's consider another tuple where a particular element is mutable data. Let's say an empty list. The second element is mutable data. It's a list. Now, if I create a deep copy of this, now T4 will not be same as T3, meaning T4 and T3 are not pointing to the same object. T4 is object whose ID is different from T3. Now, of course, the content of T3 and T4 will be same. So what happened here? T4 is a new tuple, but so a new tuple, and in T4 the first element 1, the first element in T3 is again a numeric. So that object, the first element of T3, which is 1, that object was merely referenced in T4, meaning T4 0 is the same object as T3 0 because the first element of T3. Now in this case, if you see the algorithm, the else part in the second point, X is a tuple, the else part will execute. So it will create an empty list, and for every element in X, it will do a deep copy, again recursively called deep copy on E, and that deep copy will be appended to L, and from L a new tuple will be returned. So when I am iterating over T3 the elements, we have 1, the first element is 1. So what will be the deep copy of 1? The 1 itself. So we are getting T4 0 is T3 0, meaning T4, the first element of T3, the first element of T3 and the first element of T4 is basically the same object in memory. But this will not be the case for the second element, because the second elements are mutable data. So they are different. The second element of T4 is a completely different object, which is the empty list, and the second element of T3 is also a different object but an empty list. Meaning if I modify the empty list of T4, it will not affect the empty list of T3 and vice versa. Let's check that out. If I do append, let's say append 0 and check T4. So 0 has been appended in the second element empty list of T4, but T3 is the same. It did not affect T3. Okay, so this was for tuple. Now let's see for list and set. Let's say we have a list, and for list basically let's say okay, so I have this list. I have list. The elements are, the first element is a numeric, the second element is a string, the third element is a tuple which contains the tuple. All the elements of the tuple are immutable data. The fourth element is also a tuple where the first element is immutable but the second element is a mutable data, which is an empty list, and the last element is a dictionary where the value of key 1 is a immutable data, which is a string, and the value of key 2 is a mutable data, which is a list. Now let's see how deep copy works on L. If I make a deep copy of L, definitely since L is a list, I will get a new list. A new list, I mean a new object which will be a list. By that I mean L2 is L will definitely be false, since will be false. Now let's check the individual elements of L2 and L1. Now, since it's a list, the algorithm will work similarly as the else part of the tuple. So it will iterate over all the elements of L, and it will recursively call the deep copy of that element and put that deep copy in L2. So first element of L is a numeric, it's a immutable data. So definitely L0 will be same as L2, because it is iterating over all the elements of L and recursively calling deep copy of each element of L and putting the deep copy into the newly created list. So when creating a deep copy of 1, it will simply return that object and put in L2. So we are having L0 is L0 and L2, L0 and L20 are the same object. Similarly, it will be same, since the second element is a string, it will be same object. The third element is a tuple where all the elements are immutable. So 2, L2 2 and L2 will also be the same object. Now the fourth element of L is a tuple, but this tuple contains one empty list which is a mutable data. So now T3, L2 3 and they will not be same object. This is false. This is false. But see that L3 is the tuple L3 is the tuple def comma empty list. If I want to check whether the string def, I mean this is this, it will be true. When the second tuple in L1 that was being deep copied, then recursively it was again calling deep copy, and that it was a tuple with immutable with one immutable data, but while iterating over all the elements of the tuple which are def comma empty list, but def is a immutable data, so that object was pretty much referenced in the tuple in L3. I hope the code snippet I am using is helpful. Now definitely L3 1, which is the empty list of the second tuple, will be not the same as L2 3 1, because empty list is a mutable data, while deep copying a new empty list will be created. Now now let's see the dictionary element, the last element. Now L2, so L2 0 1 2 3 4, so 4, L2 4 is a dictionary, and if I compare the value of key 1 with this, both the values are the value of key 1 in the dictionary is a string, which is A, which is a immutable data. So they will be same. But the value of key 2 in the dictionary is an empty list, which is a mutable data. So the value of key 2 in the deep copy, that is in L2, will not be the same as the value of key 2 in the dictionary of L. This is false. I hope you got the idea. So this was this, and okay. So now okay, so I hope you got the idea of how deep copy is working recursively and for all the data types. I have discussed only the data types, numeric, string, range, tuple, list, set, and X dictionary. Okay, we have not tested set. Let's say we have a set. Let's say we have a set, an iterable. Let's say the way deep copy of set, it will work the same as list. So if I create a set from an iterable having some unique elements, let's say 1 comma 2 comma abc, remember that the in set all the elements need to be hashable, and okay, so if I do this and see S is this, if I create a deep copy of S, I get this. Okay, so S2 will be fine, but what if okay, so I can't how do I access an element of a set? Set is not a sequence data type. So I just want to check whether the how are the elements of S2 related to the elements of S. I mean, are they the same objects or different? I guess set how to, I don't think we will have this. No, update is not subscriptable. Okay. I can do one thing. Since I need to access access the individual elements, I will do a little bit of cheat code. What let's create a list from the S, and let's create a list from the L2 S2, and now I can access the elements of S2 and S with indexing. Now remember, when you use list function list and you pass an iterable, then the new list, the list that it creates, it contains references to the elements from the iterable. When you do list, this should be how does it works? Let's say this function list, let's say x is an empty list, it creates an empty list, and then for element in iterable L dot append E, and then it returns E. Here E, all the elements in iterable, here E is a reference to all the elements in iterable. It's not a copy of the element of iterable. This E is a reference to the elements of iterable. So basically, the E we are appending to L, all those elements are basically referencing to the elements of empty list, meaning they are the same pointing to the same objects. So, and then we are finally returning the E, returning the list L. So this is pretty much the algorithm of how list function works. So list is a built-in function. It takes an iterable and it creates a list from where the list contains the elements from the iterable. Okay. Now I want to see. So this was set. We have a deep copy S2 list. S2 list will have the elements of S2 list will be the elements of S2 will be the same as elements of S2. Now I can now do this is S list. Of course, it will be true because the first element of the set S was an immutable data type, which was numeric 1. 1 will also be true because the second element in the set was 2. It's a numeric. And also the third element is string, it will be true. But what if, let's say, we have S3 equals to a set from an iterable, let's say 1 comma an empty list. So I am having an element in the set as an empty list, but will it what? No. Unhashable type list, no. So in set you cannot have a, a list, because a list is a mutable data type, and mutable data types, basically list is not a hashable. List is not hashable. So yeah, every element of a set has to be hashable element. So you cannot have a list as an element of a set. Anyway, okay. So the algorithm for creating a deep copy of a set will work the same way as a list. Now, okay. So that was all for how a deep copy works in Python. I hope you understood the algorithm. If you have any doubt, you can always ask me in the comment section, and I will do my best to clarify your doubts, and we can have a discussion over there. Now, one thing I would like to say about the shallow copy, that in the previous part 1 video I talked about shallow copy. Sorry friends, there was someone at the door, so I was not in front of the machine. Anyway, so so regarding, I would like to say something about the shallow copy of an object. Okay, so we we in the previous video we discussed about shallow copy. Now, please note one thing, that let's say when you are creating a shallow copy of of a mutable data, like say list or even set or a dictionary. Let's say I am creating I have a list, let's say 1 comma 2, let's say a tuple 3 comma 4 and a string. So what happened? Unexpected indent. Okay. So I have a list. Now I create a shallow copy of using the copy function from the list L. Now so L2 is a shallow copy, meaning now, so what is the difference, what is the fundamental difference between a shallow copy and a deep copy? Now, in a shallow copy, if you, this L2 is a shallow L2 is a shallow copy, if you add an element, or remove an element from L2, it will not affect L, and vice versa. If you add an element or remove an element from L, it will not affect L2. But since it's a shallow copy, all the individual elements of L is being shallow copied to L2, meaning the L2 merely has references to all the elements of L. So if you modify, a particular element, in L, that modification will also be reflected in L2 and vice versa. Meaning, so let's first see that if I add an element to I'll add 0 to L, I get this 0 is added, but see L2, 0 is not added to L2. So when I added an element to L, it was not added to L2. So if I add an element to L2, it will not be added to L. Similarly, if I if I remove an element from L, it will not affect L2. If I remove an element from L2, it will not affect L. So removing an element or adding an element from a shallow copy, if you from a if you shallow copy will, does not affect the original copy. But if you modify a particular element in place, now see, for this list L, I cannot modify any elements because all the elements are here immutable. Let's consider, let's say I have a list L3, something like the first element is also a mutable data list and this. Now I create a shallow copy of L3. Now, so L4 is this, L3 is this. Now, if I add an element, if I modify the first element, now the first elements of both the shallow copy, that is L4, and the original copy L3 are mutable data. It's a list. If I add an element to the first to the empty list of L3, it will also be added to L4. The first element of L3 is 0, which is the empty list. If I add an element 1, and you see L3, the 1 is added, you see L4, 1 is also added there. So the point I am trying to make is, in a shallow copy, in the case of shallow copy, when you create a shallow copy, if Y is a shallow copy of X, if Y object is a shallow copy of X, and let's say, for the sake of discussion, X is a collection object, a container object, like a string, like let's say in any collection object. It could be list, it could be set, a dictionary, it could be a tuple. So when you create a shallow copy Y from X, then if it's possible, if you add an element or remove an element from Y, it will not affect X. And if we add or remove an element in X, it will not affect Y. But if you modify a particular object in X, that modification will also be reflected in Y. Now, by modification, I do not mean you assign a, when I say, okay, let's try to understand here. Let's say X is a some collection object. X is a some collection object. It has some elements. Okay, let's say this element is A, this element is B, this element is D. This you create copy shallow copy of X, and you got Y. So you will have now this. Now if I add an element to Y, 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 this will not be added to X. Similarly, if I add an element here, G, this G will not be added to Y. Similarly, if I remove A from Y, that A will not be removed from X. Now, when I say, if you modify a particular element, let's say we are trying to modify the third element, that is C. If you modify this, then this modification will also be triggered here. Now, what do I mean by modifying a particular element in Y? So let's say this is a list for the sake of understanding. So we have 0, 1, 2, the index, and over here we have index 2, 3. By modifying the third element, I am not saying you are doing this. some object. No, I'm not saying this. By this you are assigning a completely new object to y2. I'm not saying this. I'm saying you are doing some operation on y2. Let's say you are doing something like this. Let's say if y2 was an if y2 was a list, you are appending some element to y2. Or if y2 was a dictionary, you are adding a dictionary, you are adding a key to a dictionary, or removing a key to dictionary, or updating the value of the key. Or if y2 was a list, you are removing an element from y2. Then in that case, all those effects would have also affected the element x2. This is what I am saying by modification. So I hope this video gave you a better insight of how deep copy and shallow copy works in Python. I just demonstrated with the built-in, with some very standard built-in data types like numeric string, tuple, range, list, set, and dictionary. In the next video, I will discuss how a user-defined class, that is a custom class, can be used, how they work in terms of shallow copy and deep copy. I mean, when you please note that when you do copy, when you call this function copy, this is shallow copy x, and this internally if it checks that if x is a built-in method, if x is a built-in method in Python, then it will surely have the implementation of shallow copy. Now, shallow copy, for any data object, for any data type, to support shallow copy, it must implement the protocol method __ copy __. So object dot, this is the protocol method for object, for a data type to support shallow copy. And for deep copy, similarly, it is dot __ deep copy __. So when you do when you call this, it sees if x is a built-in data type in Python, then it will simply call x dot __ copy __. Since x is a built-in data type in Python, it will surely have an implementation of the __ copy __. And similarly for copy dot deep copy x, it will call x dot __ deep copy __. Now, if x is a user defined function, is a user defined class, is a custom class, then it will check that if the class has an implementation for __ copy __, then it will call that function. And for deep copy, it will check whether that custom class has implementation of __ deep copy __. It will call that function of the class. Now, what happens if a user defined class do not have either of the protocol method, that is __ copy __, or __ deep copy __, that I will discuss in the next video, and I will try to create a custom class and implement this protocol method, and we can write our own way how to create a copy, a shallow copy and a deep copy of our custom class. So that was all for this video. Thanks for watching. Until the next video, take care and bye.